Hey everyone, welcome to day 2 of learning generative AI. But today in this video, we are going to understand how does AI think and predict, which is pretty common question. Like if you are really interested in generative AI, you should have this question to you that how does AI think? Suppose I'm asking some question, then how does AI predicts that? What is the real reason and what is the real key concepts and mathematics that involved in this concept? So today we're going to understand that using simple mathematics, that is vector addition and subtraction. So in the last video, I explained what is scalar, what is vector, and what is matrix, and what is the real application of all these things in generative AI, not in AI, machine learning, and all these things. Okay. So today we are going to understand how does AI think and predict using vector addition, subtraction, what is their role in AI. Well, let's get started. Now let's understand what is vector addition and subtraction. We'll start with vector addition. Suppose you have one number, suppose you have one vector A equal to 1, 3, 5 and B equal to 7, 2, 3. So what will be the vector addition? That is A plus B will be, so we have to add them element wise like this. 1 plus 7, 3 plus 2, 5 plus 3 like this, okay? So now once we add them, we'll get a new vector. Okay, that is 1 plus 7, comma 3 plus 2, comma 5 plus 3. Now 1 plus 7, that is 8, 3 plus 2, that is 5, and 5 plus 3, that is again 8. So we got a new vector that we got after performing vector addition. Then let's understand how to do vector subtraction. All right, for that, we have to write A minus B equal to, what is the value of A? That is 1. 1 minus 7, 1 minus 7, comma 3 minus 2, comma 5 minus 3. This is how we should do vector subtraction. That is 1 minus 7, that is minus 6. 3 minus 2, that is 1, and 5 minus 3, that is 2. This is vector subtraction. And we got a new vector after performing all the vector addition and subtraction. Okay, this is how you can perform vector addition and subtraction. Now let's understand how these vector addition and subtraction are useful in AI, especially in generative AI. Now let's understand a key concept. What happens when we predict something? Let's suppose our input becomes 0. Okay, then the outcome, like we have an equation like this. Let me tell you the equation. We have an equation, suppose prediction. One prediction is equal to 1 Newton. Okay, so Newton 1 is equal to x dot w plus b. This is the equation that we follow to predict on Newton. Okay, one output. Okay, what is x here? X is nothing. Is the input. Then what is W? W is weight. And what is B? B is bias. Now try to understand one thing. So X plus W, here we perform dot product. Okay, that is a different thing. In the next video, we will understand what is dot product. The thing is, once we predicted X and W, we have to add B, that is bias. Why we have to add B? Because sometimes if input feature becomes 0, suppose X equal to 0, then our total prediction will become 0, because 0 into anything will become 0. So now to avoid our decision to be null or invalid, we have to add the bias. The bias is just a number which avoids, which helps the model. To help the model to avoid the prediction to become null. So this is why we use bias. Bias can be actually the bias. The machine learns how to find the bias on its own. And the weight also, like weight and bias. The machine has to learn on its own to find how to find the bias and how to find the weight. But the first weight we have to assume. Suppose I assume something here. The input feature, suppose it was uh, 30, 80, and 90. This is my input feature. And then weight, suppose 0.4, 0.3, 0.1. After multiplying them, we'll get another vector that is 25 or 30 or 15. This we get the feature. Okay. So now we have bias for one. Each of them we have bias. Suppose I have the bias here. Suppose I have the bias b equal to 0.2, 0.3, 0.4. So what I have to do, I have to do vector addition so that my prediction will not become zero or none. That's why I will use bias, and I'll have to add them with my prediction. That is 25 plus 0.2, comma 30 plus 0.3. Then what is the next number? 15 plus 0.4. This will be my prediction. So now what I'm doing, I'm adding bias to my prediction to avoid my prediction to become null or invalid. This is why vector addition is important. Are you getting my point? So now let's understand what is the role of vector subtraction. Let's imagine you predicted a score. Suppose my prediction was, I would say, Ravi would score 80% in board exam. Hari would score 90% in board exam. And Sneha would score 30% in board exam. That was my vector. I predicted for 3 students. That is my prediction. But the reality was something. The reality was Ravi scored only 70% and Hari scored only 35% and Sneha scored 80%. That means there is a mismatch of my prediction and my reality. So what I will do that means if there is a mismatch, that means there is an error. So to avoid error, I'll have to find out the error rate. Okay. So now what I will use vector subtraction. That is prediction minus reality. That is error. And we find error using vector subtraction. Then you should ask me, sir, why do we need to find error? Now we find error so that we will adjust our W. As I told you, W is the weight that we assume, or we as the first thing we have to assume. A later machine will learn what is the weight for each subject or each feature, so that we can adjust our weight and bias. Then only we will get our correct prediction. This is why vector addition and subtraction plays a critical role in AI. If you understood, now let's do the math using NumPy in Python. So now what you do, open Jupyter. They will learn how to do all this vector addition and subtraction in NumPy. Hope you understood today's concepts, vector addition and subtraction, and the analogy, like how these vector addition and subtraction are used in Python. So now, as I told you, to use NumPy, we have to import it first because I'm using Jupyter, so I always have to import NumPy as NP. I'm just abbreviating NumPy as NP. So shift enter. Then what to do? That's right. We have to define a new array. Suppose A vector was np.array, then parentheses and close parentheses, then bracket, all right, 2, 3, 8. This is my vector 1. Okay, that is vector A. And then vector B equal to, I'll just copy and I'll change the numbers only. Oh, code all these things. This is boring. And one more thing, you have to practice a lot. If you read today, if you watch the video today and tomorrow you are not practicing, you'll forget everything. So you have to practice. So I'll just change the numbers. That is 4, 7, 9. All right. So I got two vectors here. So what I'll do, I'll just print A plus B, A plus B. Here we go. And print A minus B. A minus B, A plus B is for vector addition. Vector addition. And A minus B is for vector subtraction. Vector subtraction. Now let's execute this code. Now, as you can see, we have predicted, like not predicted, sorry. So we have added our vector A and B, and we got the output 6, 10, and 7. As I told you, once you add two vectors, you will get another vector. And once you again subtract two vectors, you will get another new vector. So we got two new vectors here after addition and subtraction. So there we go. We finished vector addition and subtraction, and we coded them using NumPy in Python. Hope your journey to generative AI is going smoothly and fine. Stay tuned for the next video, and in the next video, we're going to discuss the dot products and the vector or scalar matrix multiplication. All these things. Stay tuned. Till then, bye bye.